So 8B, we are going to be taking kind of what we learned in 8A, which was exponents, and now we're taking it one step further into what we call logarithms. Logarithms are just a notation of writing exponents, okay? So you guys remember back in 7th grade when you learned scientific notation? And it's a different way of writing a really, really big number or a really, really small number. Yeah, times 10 to the negative whatever, or times 10 to the 8th power. A logarithm is just a different way of writing an exponent, okay? So I'm going to give you a little chart that kind of tells you how an exponent relates to a logarithm, and then we're going to do some examples. So in your exponential function, you had been getting stuff like n equals b to the power of p. So n, b, and p would all have been numbers. N is your number or your answer, B is your base, and then P would have been your power, and those would have actually all been numbers. If we were to rewrite this as a logarithm, your number or your answer now becomes what you are taking the log of. Your base of your exponent is what's called the base of your logarithm, and your exponent becomes what the logarithm is equal to. So it's just taking all the different parts and putting them in a different notation. We would read this as P equals log base B of n. Okay. Another way that you can think about this is you will be getting problems that look like log base B of n equals P. So this is just the same thing rewritten in a different order. Mostly you will see it rewritten like this. To change your log to an exponent, I call this going up and around. So you start at your base, so that's the base of your exponent, go up to your power, so it gets raised to the power, and come around to your answer, so equals your answer. Okay? And all we're going to be doing is going back and forth between the notations today. Okay? So today we're going back and forth between the notation. Let me show you with numbers in an example, and then it should be a little bit clearer. So here's your first example. Log base 5 of 125 equals 3. That's how we would write it, okay? Log base 5 of 125 equals 3. Okay? So what you guys are going to do first is, for this one, I'm going to have you identify each of the parts, and then we will rewrite it as an exponent, and then we'll just do a whole bunch of examples rewriting them as exponents, okay? So, my first question to you is, what is the base? So in my log, the base is a small number, and that's the same as the base in your exponent. So in this example, what is the base? 5. Okay. Now what is the exponent? So in an exponential equation, your exponent is right here, and that is what we set the whole thing equal to in the log. So in this problem, your exponent is 3. So let's think about this. If your base is 5 and your exponent is 3, 5 to the third equals 125. Is that a true statement? So it's just taking an exponent and rewriting it in the notation of logarithms. Now we're going to be starting really simply today and just going back and forth, but the whole purpose of all of this is there will be problems that are easier to solve in log notation. So right now we're just getting used to the log notation, and then eventually we'll get to more difficult problems where it's easier to solve them when they're in log notation. So example 1, I have log base 6 of 216 equals 3. Question, what is the base? 6. So if I wanted to rewrite this as an exponent, it would be 6 to the power of 3 equals 216. I'm not asking if the statement is true or not. I believe all of them should come out to true statements, because right now we're just getting used to rewriting it in the exponent notation. So whatever your base is, that's the base of your exponent. The whole log is equal to your exponent, and then we set it equal to what you're taking the log of. Okay, so let's look at number 2. What is the base here? 4. What is the exponent? 4. And it all comes out to 256, which is a true statement. So guys, how would you rewrite log base 5 of 1 equals 0? 5 to the 0 equals 1. Is that a true statement? Mm-hmm. Okay, so what I'm trying to show you is that a log and an exponent are actually the exact same thing. Okay, it's just a different way of writing them. What about number 4? What would you get? 2 to the negative 2 equals 1/4. Okay, easy? Okay. Let's look at number 5. Number 5, what do you notice is different about this one than the 4 problems we've already done? It doesn't have a base. If there's not a base written, we call that the common base, which is a 10. So it's kind of like writing 7 over 1. You don't have to write the 1, right? If you have a base of 10, you don't have to write it. So if there is never a base written, assume that it's a 10. So this is going to be 10 to the negative third equals 0.001. Okay, and remember, powers of 10, the exponent tells you how many spaces you move the decimal place. Okay. Guys, we have log base 7 of root 7 equals 1/2. What did you get? 7 to the 1/2 equals root 7. True? Mm-hmm. Okay. What about number 7? There are no numbers in here at all, but you can still do the exact same thing with variables. So we have log base r of n equals m. What's your base? R. What's your exponent? M. And the whole thing is equal to? N. So it's the exact same thing. You start at your base, you go up and around. There's just no numbers involved, but the process is exactly the same. And then the last one, log base 5 of 5 equals 1. What did you get? 5 to the first equals? True? Yes. Mm-hmm.